Have you ever really stopped to think about what's going on inside a router? I mean, seriously, this little box makes billions of decisions a second, guiding our data across the entire planet. How does it do it? Well, today we're going to peek inside the mind of a router. We'll follow one single data packet on its journey to see how it all really works. So, let's meet our hero for this trip, a single data packet. Its entire mission, its whole purpose in life, is to get from PCA all the way over to PCB. And standing in its way are the gatekeepers of the network, routers. But don't think of them as simple toll booths just waving traffic through. Oh no, they have to make a smart, calculated decision for every single packet that crosses their path. To really get how a router makes these choices, you have to understand that every router has this kind of split personality. It's got two fundamental jobs, two directives that guide everything it does. One is all about thinking, and the other is all about acting. On one hand, you've got path determination. This is the router's brain, what we call the control plane. It's where it builds its internal map of the entire network, figuring out all the possible ways to get from here to there. And on the other hand, you've got packet forwarding. This is the muscle, the data plane. It takes the decision from the brain and physically shoves the packet out the right door. So, thinking and acting, two totally separate but connected jobs. Okay, so a router can't act without a plan, and it can't have a plan without a map. But how does it even build that map, its routing table? I mean, where does all this incredibly important information come from? Well, the absolute most basic way a router learns anything is just by, being aware of its own existence. When you configure an interface with an IP address and turn it on, the router automatically goes, aha, I know about this network now. It adds it to its map, basically saying, hey, I am physically plugged into this neighborhood. This is the very foundation of all its knowledge. Next up, we have static routes. Now, this is where a network admin, a human, steps in and basically gives the router handwritten directions. It's like telling your GPS, look, I don't care what you think the best route is. To get to this specific place, you are going to go this exact way. It's perfect for simple networks or anytime you need absolute iron-fisted control over how traffic flows. But let's be real, you can't manually configure the entire internet. And that's where the real magic happens. Dynamic routing protocols. This is where routers start talking to each other. They're constantly gossiping, sharing updates about all the paths they know about. They build this incredibly detailed map of the network together. And here's the amazing part, they can self-heal. If a connection somewhere dies, they all find out about it and automatically figure out the next best way around the problem. It's a living, breathing map. And finally, every good map needs a catch-all, and everything else option. That's the default route. Think of it as the router's safety net. If a packet shows up and it's headed to a destination that is not on its detailed map, the router doesn't just panic and drop it. Nope, it just sends it along the default route, which usually points out towards the bigger internet. It is truly the gateway of last resort. All right, so the map is built. The router has learned about paths from all these different sources. Some it knows intimately, some it was told, some it learned from its neighbors. Now for the moment of truth. A packet arrives. With all that information, how on earth does it pick the single best path? So, let's make this real. A packet shows up and its destination IP is 172.16.0.10. The router glances at its map and sees 3 different routes that could all, technically, get the packet there. So which one does it pick? And maybe more importantly, why that one? The answer is the first and most important rule in all of routing. Always choose the most specific path. This is the longest match rule. The router looks at the packet's destination and compares it bit by bit to the routes in its table. It's looking for the entry that matches the most bits. And as you can see right here, Route C has a /26 prefix. That's a way tighter, more specific address range than the others. So Route C wins. Every single time. The most specific route always wins. But wait, that leads to a fantastic question. What happens if there's a tie? What if you have 2 routes to the exact same destination with the exact same prefix length, so they're equally specific, but the router learned one from a static route you typed in and the other from a dynamic protocol like OSPF? Now what? How does it break the tie? The tiebreaker is a really cool concept called administrative distance, or AD for short. The easiest way to think about this is as a trustworthiness score. Every source of routing information gets a number, and the lower the number, the more the router trusts it. A directly connected network has an AD of 0. You can't get more trustworthy than that. A static route is a 1. A protocol like OSPF is way down the list at 110. So in a head-to-head battle, the router will always believe the static route over the OSPF route because it has that much lower, more trustworthy AD. So there we have it. The router has built its map, and it's used its logic to pick the absolute best path. The thinking is officially done. Now it's time for the final piece of the puzzle, the physical act of actually getting that packet out the right door. This whole forwarding process breaks down into 4 lightning-fast steps. 1, the packet arrives on an input or ingress interface. 2, the router does that super quick lookup in its table. 3, it wraps the packet in a brand new frame for the next leg of its journey. And 4, it shoots that frame out the correct exit or egress interface. In, lookup, wrap, and out. Simple as that. Now this brings us to an absolutely critical concept in networking, so lean in for this. Notice how the IP address, the ultimate source and destination, it stays the same for the whole trip. Think of it like the final mailing address on a package. But the layer 2 MAC address, that changes at every single router, at every single hop. That's just the address of the very next device in the chain. Understanding this difference is key to understanding, well, pretty much everything. And of course, all this forwarding has to happen at insane speeds. Over the years, the tech has gotten just ridiculously fast. Back in the day, process switching was like doing long division by hand for every single packet. It was painfully slow. Then we got smarter with fast switching. That was like solving the math problem once and just remembering the answer for the next time. But today's standard is Cisco Express Forwarding, or CEF. And this analogy is perfect. CEF is like having a pre-calculated cheat sheet with all the answers ready to go before the test even begins. It is pure, mind-bendingly fast efficiency. So we've seen how a router learns, how it decides, and how it acts. Let's just pull back for a second and see how all these pieces fit together in one elegant, non-stop cycle. And it really all comes down to this simple but powerful loop. First, learn. The router builds its map using everything it knows and uses administrative distance to rank how much it trusts each piece of info. Then, decide. A packet arrives, and the router uses the longest match rule to find the most specific, best possible path. And finally, act. It repackages the packet and forwards it out the correct interface using a super efficient system like CEF. Learn, decide, act. This loop is the very heartbeat of the network, beating billions of times every single second. You know, the logic inside a router is incredibly elegant, it's fast, and it's reliable. But that also means this one device is a huge point of control and a huge point of potential failure. So the real question becomes, how do network operators, the people who build and maintain our digital world, make absolutely sure that this silent hero is always making the right choice? Now that is a very deep question, and one we'll have to say for another day.